Hey, so I wanted to go over what we went over today in class because I felt like it was confusing and there's just a lot of people talking and there's just a lot going on. So I copied down the pedigree and essentially the two parts of the problem that we care about. First part of the problem is, what is the probability that kid at the bottom of the pedigree is affected with this recessive trait? And the second part of the question is, what's the probability the kid is a carrier for this recessive trait? So the first part of this problem, like we went over in class, is to figure out everyone's phenotypes. So we have two parents that aren't showing the phenotype producing a child that does show the phenotype. Let me cut off the camera. That's okay. So we know that these guys are going to be heterozygous. And we know that because heterozygous crosses are the only ones that would produce an affected child with two parents that don't show the phenotype. Which means that we know that this child is A dot dash, A dot dash. Because we know they show the dominant phenotype, but we don't necessarily know what the second phenotype is. We can go over to the other side and we see we have an affected parent and an unaffected parent. Affected parent's going to be double recessive. Double recessive. These two kids are going to be double recessive. And we know that the other parent has to show some kind of dominant phenotype. And we also know that they have to have a recessive phenotype so that way we could have two children that are affected. This child we know has the dominant trait, but not necessarily what the second trait is, so we're going to put a dash there. All right. This is the part where everyone starts getting confused because we have to start figuring out probabilities. So we have a marriage event. Where they show that they're going to be double dominant just because that's given in the question. Marry in, we have a known parent. They're 100% going to be heterozygous because we are crossing a double dominant with a double recessive. No matter what they produce is going to be heterozygous. Unfortunately, though, for the dad in this cross, we don't actually know what his second trait is going to be. We don't know if he's double dominant or dominant recessive. So what is the probability that the dad is going to be dominant recessive versus the probability that the dad is going to be dominant?